Hi everyone, welcome back to our channel. Today we are going to find the input impedance for this ideal transformer which has primary winding as well as secondary winding, and it is connected with the load impedance of ZL, and here the current flows in this direction as I1. Okay, and let's try to label this current as I1, and the current which flows in this direction is I2. So these two are isolated, they are not coupled. Okay, so, but they are coupled with the mutual value of SJXL. Okay, so let's try to do it. So let's try to apply KVL at the loop 1. Okay, so loop 1, we need to see that we require Z11 is equal to V1 by I1. This is what we actually require. Okay, let's try to do it. Okay, so let's try to apply at input side. So applied voltage is how much? V1 is equal to, so what is the impedance offered here? Whenever it is entering and leaving, it's nothing but the drop. We are writing it as I1 into R1. Okay, and here it is having the resistance of plus J X1. This is nothing but R into I. I value is how much? I1. Okay, so with this first branch is completed, but it is having a mutual inductance for these two coupled coils. You can see here for the first current I1 dot is there at entering, for the current I2 also dot is there at entering. Therefore, we have a positive value of mutual inductance, and that value I am going to write it as plus J. Mutual inductance value is X M ohms multiplied with. So we are writing for coil 1, then I will write down the current in the another coil, which is nothing but I2. Okay, so now let's try to take I1 as an common term. Therefore, V1 is equal to I1 into R1 plus J X1 plus J Xm into I2. So the disturbing term in this is I2. We need to express I2 in terms of I1. So this is what we need to do. First loop is completed. Let's try to apply KVL in the second loop. Apply Kirchhoff's voltage law in loop number 2 or in the second mesh. Okay, mesh or the loop both are same. So there is no voltage source. Okay, so I'm writing source is 0, and the drop I'm going to get it as positive, negative. So therefore the drop is how much? So I into R. R value is how much? ZL. Okay, and it flows here also. So it's nothing but plus J into X2. Okay, so this is nothing but I into R. R value is how much? J2, and I value is I2. And so here the drop is plus I into R. I into R, which is nothing but R2, but these two are mutually coupled. We have tried down for these two coils. Okay, so this is nothing but self inductance, and we have tried on the mutual inductance. Current is there at entering, and here also current is there at entering the dot. Therefore, we get positive mutual inductance, where the value of this is the resistance offered is plus J Xm into, we are writing for the second coil, automatically refers the primary coil, which is nothing but I1. Now let's try to segregate the I1 terms and I2 terms. Okay, so now here you can see here, this is also I2 term, this is also I2 term, I2 term. So 0 is equal to take I2 as an common term. Therefore, we are going to get R2 plus J X2 plus ZL is the I2, and plus J Xm into I1. Okay, so this is what we are getting here, and we require the value of I2. Okay, so this is what we need to do. So how to get the value of I2? It should be in terms of I1. Okay, so this move this term to here, we are going to get minus J Xm into I1 divided by R2 plus J X2 plus ZL is equal to the value of J X M. So this is the value of I2 to what we are going to get here. Okay, So this is the I2 value what we are getting. So this I am sending to this side and I have got the value of I2. Okay. Now directly substitute the value of I2 in this equation. Therefore you are going to get V1 is equal to I1 into R1 plus J X1 plus J XM ohms multiplied with I2. I2 value is how much? Minus J XM into I1 divided by R2 plus JX2 plus ZL. Just see here, move this I1 to the denominator. Let's try to take I1 as an common term. Therefore, V1 is equal to I1 into R1 plus JX1. So plus into minus is how much? Minus J square, and here you are going to get this value is xm, and this value is also xm square into I1 divided by R2 plus jx2 plus zl. Okay, move the I1 to the denominator. Okay, so take I1 as a common, then V1 by I1 is equal to, we are going to get R1 plus jx1. Okay, so this is what we are going to get now. Okay, R1 plus jx1, and this we can write when it as j square is minus 1, minus into minus is how much? Plus, you are going to get x m whole square divided by R2 plus j x2 plus ZL. This is the total amount of input port driving point impedance offered by the transformer. Okay, so for these types of transformer, this is the amount of input driving point impedance offered. Just write down the KVL at loop 1, write down the KVL at loop 2, and see that we should have V1 and I1, but I2 is there unfortunately, and express I2. So we are expressing this I2 completely in terms of only I1. Just substitute in this equation, then you are going to get the input impedance. So if you feel my explanation is good and you are very happy, please like to my video, and those who are studying the same subject, share to your friends, and if you have any doubts, let me know in the comment section, and kindly subscribe to my channel, the name kvthulasi. Okay, so this is a free channel for the development of students and faculty. Kindly encourage this sort of channels. Okay, hope we'll meet with another beautiful problem. Yours Ram.